6.3 Application of linear law. The table shows the values of two variables x and y obtained from an experiment. The variables x and y are related by the equation h over y equal k over x plus 2, where h and k are constants. So here are the given table x and y, but the questions when we plot 1 over y against 1 over x. So we have to construct table 1 over y and 1 over x. Second, draw graph 1 over y against 1 over x. Third, find gradient and y-intercept. Fourth, reduce equation to find the constants and solve problems. So we have constructed the table to find 1 over y and 1 over x. So for 1 over y, we have to find 1 over 0.586, which is equal to 1.71. Put it in the table. And the second value is 1.44, 1.28, 1.04, 0.96, and last value is 0.80. To find 1 over x, we have to find 1 over 1.5, which is equal to 0.67. So we put the value into the table, 0.67. Next value is 0.50, 0.40, 0.25, 0.20, and last is 0.10. So now we are ready to plot the graph. By referring to the equation, plot 1 over y against 1 over x, so we write 1 over y on the vertical axis and 1 over x on the horizontal axis. Using a scale of 2 cm to 0.1 unit on the 1 over x axis, so 0.1, here is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, and last is 0.8. Next, 2 cm to 0.2 unit on the 1 over y axis. So here is 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8. Because the largest number in 1 over y is 1.71. Now we are going to plot the graph. So here is the coordinate 0.67 and 1.71. So we mark the point here. Second coordinate is 0.50, 1.44. So we mark it here. Then we continue with other coordinates until we finish plotting the graph. Hence, we draw a line of best fit, a straight line that joins most of the points plotted on the graph. Please use long ruler and elongate the line so that it passes through 1 over y-axis. Easy for you to read the y-intercept later. Next, find m, gradient, and c, the y-intercept. So we find the gradient first. Make sure that the coordinate that we choose are on the line of best fit. So I choose 0.10, 0.8. Second coordinate is 0.67, 1.71. So we find the gradient. M is equal to 1.71 minus 0.8 over 0.67 minus 0.1. So m is equal to 1.60. C, the y-intercept, we get it from the graph. So the value of C is equal to 0.64. Now we are going to reduce the equation, so we rewrite the equation given in the question. H over y equal k over x plus 2. So the left hand side, our target is 1 over y because the graph is 1 over y against 1 over x. So the target is 1 over y on the left hand side. So we have to divide it by h over y, h equal, when we divide it with h on the left hand side, so we have to divide with h on the right hand side too. So h over h we can cancel out, become 1 over y equal k over h, 1 over x plus 2 over h. The equation now are in the form of y equal mx plus c, where k over h is equal to m and 2 over h is equal to c, the y-intercept. So 2 over h is equal to 0.64. 2 over h is from the equation and 0.64 is from the calculation. Solve it and you will get the value of h is equal to 3.125. Here is the equation 1. For B2, from the equation, you know that k over h is equal to the gradient, so k over 3.125 equal 1.60, so k is equal to 5. B3, find y when x is equal to 3.2. We cannot read the value directly from the graph because the graph is 1 over x-axis, so you need to find 1 over x first. So 1 over x is equal to 0.31. From 0.31, move up a dotted line like this, then move to the vertical axis. You will get 1.14. This is the value of 1 over y, so 1 over y equal 1.14. Rearrange it, you will get y is equal to 0.877.